going to talk about Kafka Streams and Kafka KSQL this evening, and whatever else people want to talk about. Feel free to ask me questions throughout the night afterwards. I'll be around, but to try to remain on schedule, and as Josh said, we'll try to stay to my 30 minutes. So coming into today, I wanted to talk about streams. I wanted to talk about KSQL. And I wanted to come up with a problem that would help showcase some of the new features of KSQL 2.0. I hope that's what I've achieved here, and I hope it also leads into what others will be talking about later as well. So we'll get past the who am I. I'm been with Object Partners, and I am a core developer here and director of real-time data. I've been with Object Partners for 18 years. This is what I currently do, mostly Kafka, a lot of Spring, some Cassandra, and a little bit of some other stuff. My talk this evening, I will eventually be getting it out on GitHub and available for people to explore or use. It's not quite to the level where I'd like it to be yet, but as we all software develop, it usually never is. And then Object Partners, we've been around for over 20 years, do a lot of enterprise software development. Chris Burgett, the CEO and founder, is also audiovisual tonight. If you haven't met him, feel free to talk to him later. So in order to get into my talk of KSQL, I wanted to build an application to demonstrate the features that are now available in 2.0. So in doing that, I had decided to build an application around OpenSky data. OpenSky provides aircraft telemetry around the world through transponders and provides an API that you can use to collect that data. So I wrote a Kafka connector to consume that data and to then solve two problems. And I'm going to showcase that here and then dive into using KSQL to replicate what I did using Kafka Streams. So at first, I am going to show you the result of what the application does and hope that I can then highlight how I use Kafka Streams to achieve that and how I was able to use the new features of KSQL. So the first one is nearest airport. So I read in this stream of data, and I'll show that in a bit, of all the aircrafts within the United States. I decide to break that up into two teams, the red team and the blue team. There's no rhyme or reason behind how that was done. Once I get that data into KSQL, or from the connector into the Kafka topic, I'm consuming that by a microservice consumer and displaying that here, leveraging D3. And that was a lot of fun trying to figure out how to do. It's pretty awesome. If you haven't used D3, I highly recommend it. So in here, I have all those records that I am pulling from my Kafka topic with latitude, longitude information, displaying it on this map. The first thing that I'm doing for my stream is I want to find the closest airport for each aircraft. So in there, I am now pulling in stats around each airport, and I'll zoom in to Minneapolis. And according to the data that I pulled in this afternoon, Minneapolis has 12 red planes closer to it than any other airport. So that's going to be the basis of my talk in demonstrating how I achieve that through streams and through KSQL. This one, I was successful in writing both as a Kafka stream and at KSQL. My other one, not so lucky, but still kind of fun. So in this one, I'll go back to the slide first, is the nearest neighbor. I wanted to find what two planes are closer to each other. So this slide here will demonstrate that algorithm. So I take a red plane, and I want to find the closest blue plane to that aircraft. How do I achieve that? Well, it's a distance algorithm. So the trick became, how do I do distance calculation using Kafka? And that's where I came up with a fairly common approach. I take this aircraft, the red plane, and I take a 3 by 3 degree coordinate and say it's in that region. I then will take a blue aircraft and not only map it to its coordinate system, but every coordinate system around it. So basically 9 buckets. If their buckets overlap, I'll do a distance calculation. So that's the basis of the algorithm that I'll be showing here today. And to step through it, another plane comes along, their overlap distance will be done. This plane is too far away, their boundary region will not overlap, so the streams that I'm joining in Kafka will not calculate that distance. That's how I'm trying to keep my problem domain small enough to not worry about crossing too many streams. And then finally, I'll have one that's actually in the same coordinate system, match it, but then in reality, it's a one that's next to it that is the closest neighbor. So those are the 2 algorithms I'm going to show today, how I achieve them, how I use KSQL for it, and what I can't yet do in KSQL to solve this one, and I spent a lot of nights trying. So we'll go back to here, and then I will show you the map of how that looks. So I have the red team that I showed earlier for the nearest airport. Zoom in. Oh, my UI design is lacking. So I guess I'll stick to the Western states here. So now I have my blue airports. And then after this stream runs, I collect the distance only for the nearest blue plane to every given red plane. And that's demonstrated here. And all that data is calculated using Kafka Streams. And I can demonstrate what I can do in KSQL and how I could eventually get to here, but the problems that I faced in doing it. So that's the 2 things I want to talk more about this evening. Overview, I use Confluent CLI, and I highly recommend the use of that for exploring Kafka. Really easy to get things up and running and using that. I wrote one connector, a custom connector to OpenSky. I am not really going into the details of that here tonight, but it will be part of the GitHub post or submission that I do. I wrote 3 microservices. I wrote one to get me the geolocation of every lat long to airport service, trying to demonstrate how, if you have data that's not in your Stream app or not in your KSQL, how you get that data. I have a microservice for the Kafka Streams. So what I showed you there right now is written in Kafka Streams. And then I have a Kafka consumer app that reads from a variety of topics and displays that using that D3, and that's what I showed you there as well. And then I also have a custom library I wrote for writing my UDFs, my user-defined functions, that I make available to my KSQL. In doing this, you need to, and as with all development I've done for many years, it's usually about the data, how you structure your data, how you store the data, how you pass your data along. For this, I chose Abro, so I could leverage a lot of the features that KSQL now can showcase with the use of Abro. And I also uncovered some of the problems I had using KSQL to read into a consumer that I thought was interesting. The main thing I wanted to point out is I'm storing a rather, not a complicated, but not a simple flat data structure in my topics. I have an aircraft that has a transponder and a call sign. I put lat long into a separate record. A record is complete data from OpenSky that contains a variety of pieces, but the main piece really is the transponder that's in the aircraft and the location. I create a distance record for storing the distance between a red plane and a blue plane. I also then have a nearest airport. I can provide back a complete structure of the airport code and the lat long. And finally, where I showed the count of aircrafts in there, I created an Abro for that. I could have done it in JSON. I would strongly recommend, if you're exploring Kafka and Streams, to leverage and use Avro. If you want to know why, again, I'll save those for questions at the end, or anytime you want to contact me. So the Streams app is pretty straightforward for the airport count. I first need to read in from my topic and consume that into a stream through the standard Kafka Stream API. So I'm going to go over to KSQL and just dump out the stream that I did there. So here I'm going to the native topic, saying print it out from the beginning. And you quote it because KSQL is always uppercase. I didn't create it that way. And it will print out in nauseam all the red planes that I stored in there, which again is the key is the transponder code of the plane, and then I have location data and aircraft data stored within there. So that's what I did from here. I take that topic and bring it into to my Streams app. I do the same for the blue. I then do the nearest airport. And the nearest airport is calling out to a third-party service. I use a FANG REST call to get the closest airport for the given code. I use a KTables algorithm to do the distance calculation. And then I return that in my nearest airport data structure and write that out to another topic. And I could go and show that one, and I'll do that both together, try to save for time. Now, here's the interesting part, is I have that new topic that contains the red plane and the airport it's near. I now want to count. So I use a stream windowing against itself. I pick a window of 4 hours and say, give me all the red planes in the last 4 hours and count them based on the airport. In order to do that, I need to repartition my stream by airport because that's what I want to count on. One thing you'll learn through using streams is it's really important how you classify or key your data, or you're going to have a really hard time counting what you're intended to count, and you may end up getting a lot of zeros. And this is where KSQL can really come in handy in learning and understanding what's going on when you build your streams. So I group by that key, I window for 4 hours, I count them, I write that out as an integer, as a materialized table, I convert it to a stream. Here I'm taking that window key that is the airport code and the time window, and I say I just want the airport code. When I write it out to my D3 app, I don't want the time window. If I was building a real-life application, I probably would, because I'd actually want to track my aircrafts over a period of time. My Mac really had a hard time doing one round of cross-cardinality of those planes. I didn't want to keep it moving forward. I map it to my count object, and then I write it out to my red nearest airport count as my count object that I showed earlier, and then I read it into my app. So if I go here, do print, if I could remember red nearest airport count. I have my airport count data, the airport's listed twice because it's also the key. And then that's what I read into my app and I displayed in D3. So that's what happened in my Streams app. Now I want to write that in KSQL, which is one of the things I wanted to demonstrate tonight. So here on this slide, I'm showing what's the equivalent KSQL line to replicate the stream concept that I built in my Java Streams app. So I'm going to go in and create a stream for my topic. What's nice about this is I can now read from the stream, and it shows up well. I can actually use the struct options. I can do aircraft transponder and just print those out. If you really want to explore your data, if you have it in Avro or in JSON, using KSQL to just look around to see what's in your topics and your messages is pretty easy to do. So you have that available to you. I need to now build the blue plane. I'll go to that one. Did I do? I went. Nope, I was right. Now this is the nearest airport. So that first stream that I created earlier, where I was collecting the nearest airport, I am doing it here. You'll see closest airport listed there. That is not a standard KSQL function. That is a custom function that I wrote that makes the REST call to that service. Not something I would normally want to do within a stream is to make a REST call, but for the sake of the demo, it worked out fine. And that function is pretty easy to write as well. So I write that here. Now let's do so there is the lat long and airport for each aircraft transponder written between, or yeah, for every red plane, what airport is it nearest to? And then finally, and I'll show you the UDF in a second, is I count that as well. So I create that, and now while that's running, I should go look at my map app and see if it's actually running. Yes, here's the topic. You can see 620, which reminds me I need to hurry up. All the topics that were written to that map app. And again, these are all the airport counts. So now if I go to my airport map, this was the one I written in KSQL. I had a consumer already up and running. I need to reload this page. And there's the nearest airport data from the same data, but through KSQL. So what does that exactly mean? Part that was interesting is in Kafka Streams, you can dump out the topology of the stream process, which is pretty hard to read, and the next talk may give some light into it. I don't want to speak for Cliff, but I hope that I didn't mislead you where I was going today. So here I'm taking that red stream. It's doing a variety of processing, those group bys, those filterings, those processes down there, and writing it out to the nearest airport. If I look at the one through KSQL, it's a little bit longer. So in the process of it doing it, it did it differently than how my stream wrote, but we got the same value or the same result at the end. So that's a little interesting, and I personally want to understand more of why and how the topology building between writing it in Java and writing in KSQL is different. I understand some of it, and I can showcase that a little bit with the next algorithm. So the other algorithm, and this was the one that was more interesting to me, but harder to figure out in KSQL, was the nearest neighbor. How do I write code for that? So let me bring up presentation mode. In the slides, it's a little bit different. So here, the nearest neighbor is, I take the red planes, I select them, but in order to categorize them in that 3D grid, I had to key them by their region. So I wrote a class called Bucket Factory that gives me my 3x3 grid. So wherever that red plane is within that grid, I'll get the same value back. So all the planes in that red grid, as I showed in my slides, get mapped to the same key. I then select that as the key, and then I join to the blue planes. And this is where the fun began. I had to put the blue plane in 9 different keys, or I could have 2 planes in 2 different partitions that are the closest to each other, but because they're in 2 different partitions, they're not going to find. So I have to put those in that diagram. So I created a bucket factory create surrounding that created 9 buckets. The one it's in and the 8 around it, I do a flat map of that. I then stream that, put that into the value pair of that, and now I will join on that one red plane in that, or all the red planes in that bucket with all the blue planes, calculate the distance, and return that into the distance topic. You have a question?
Yeah, you mentioned calling an external service. Like, how do you avoid like
how I would normally do this one, for nearest neighbor airport, I would cache that. I would read that and have a background thread periodically fetch the new data and then through a concurrent map or whatever, refresh it. For the sake of curiosity, I didn't do that because I was curious to see if I could break anything by calling out to another one. But yeah,
I was worried about that.
It's a very good worry, and when I first was mentioning to Cliff what I was doing, that was the exact first thing. You're not going to want to do that, and I said, I know. Which reminds me, I didn't show you that function. I need to do it. There you go. There is one thing that in running streams, and if streams die and it shuts down the stream, yeah, I've had to restart my stream app. So you definitely want to make sure your stream is resilient, or you're going to have things shut down on you. And Kafka is, because consumers read sequentially on their partition, once things die, it's not just that one that's dead, they're all dead until you get that stream or that app running again. So it's very important to make that happen. Yep. So on the nearest airport, once I collect all those, then I have to do the closest. And the closest is nothing more than an aggregate of all the distances and tell me which one's close. This is pretty easy in the stream after I collect all those, how to narrow it down. The hard part in KSQL is with aggregates, you have to group on something. And when I grouped on the red plane, I lose all the other data that I needed to achieve that, which I'm trying to make sure I don't lose sight of time. But so closest airport. Here is the UDF that I wrote for that. I make a call to my other service and just return it. So yes, in my example, I could easily flood the network. But in reality, this is not how I would code it. Yep. So nearest neighbor, I showed him on there. So I'm trying to find here's the closest one in prettier form. So I was trying to see how would I do nearest neighbor in KSQL, and this gets kind of interesting. So first one is I need to create a bucket for my blue planes. So this is the bucket location here. And this bucket location is a custom function that I wrote. And if you look at the data after, you will see for any coordinate system that the plane was in, it puts it in a bucket. Well, how do I get 9 buckets in KSQL? That was my trick. I will show you from another one. So I had to create a custom function that would say, give me the western bucket for my blue plane. My blue plane's in this one. I need, well, for you guys, this one. So I create my custom function to say, give me the western one. So if I look at this, the coordinate system of 100 is going to 105, not 102 that it would have been otherwise. Trust me, I think I did my math right. So the next nice feature of KSQL 2.0 is this insert into. So I was able to insert into the blue bucket, the one with the central coordinate, the ones from the western. So I do an insert into. Now if I select from blue bucket, and let's see where, must have called it something else. You look at a plane, trying to find one that twice, and I knew that I would. What did I call it? Let's see. I just called it transponder, not red transponder. So you can see that this plane is in two different buckets. So the blue plane came in, and I'm able to count that blue plane from both locations. So if I do that 9 times, I now have the ability to join those two planes together by distance. Oh, I forgot to create the red bucket from the beginning. There's red bucket. I didn't want to have to type all in front of you. So I have the blue bucket. This is what I knew would happen if I did it wrong. One of the things that I've learned, and it is here, is if you'd ever create your topics with the wrong partition, you will then get partition mix match. And that's what happened here. Even though I was creating them with 8 or 4, it would show that. So in lieu of time, I'm just going to show the topic of distance. Oops. You will learn that from it's going to change that. They're going to make that default, or that I will get the distance of every plane. I have the red plane, I have the blue plane, and the distance of that. When I do it in KSQL, once I join and aggregate that, I lose the blue plane. Because when I write that SQL, or KSQL, I no longer have access to that. So to go more into that, and in respect for Cliff's time, feel free to reach out to me or look at the demo of that complete stream. I think the main things from using KSQL to learn from is you're going to learn to want to do earliest. So you don't, when you're playing around, you don't have to constantly be adding stuff to your topic. KSQL will create Avro objects created by a KSQL data source stream. They're a pain to read because in the consumer, if I'm using specific Avro reader, it won't know about it. So I have to use a generic reader. So if you're mixing specific and generic record readers, it gets kind of cumbersome, but it's achievable, and the demo app does show that. Minor points on KSQL, it's not SQL, just like Cassandra's SQL is not SQL. Use KSQL to use and showcase streams and writing streams. Even if you don't use KSQL in production, it's great for printing out the topics, seeing what's going on, looking at Avro. With 2.0 and the features of stream-to-stream joining that I was able to do for the nearest neighbor, the insert into, I feel it's production ready. I think a lot of teams could go out and use Kafka KSQL in production. The trick becomes when you can't do something in it, do you want 2 applications, 2 streams app, one in Java, one in KSQL, or are you just going to say, I just want to worry about the Java ones and not worry about both? So that's something to consider. And then on the roadmap is they are adding expressions in partitioning, and they're constantly improving. If you look from 1.0 to 2.0, it was a huge jump. So I can't imagine that's just going to be more. Resources around this, OPI's blog. I've written some top discussions, others have as well. The Confluent blog is an excellent resource. There's so much going on there. YouTube channel from Confluent as well. The streaming audio podcast has 3 to 4 topics on KSQL, and is an excellent one to actually listen to while driving. I don't find many top technical podcasts that actually do that. And then there's a GitHub repository for stream examples. Just want to thank Sarah for all the work and support she's given me with a lot of stuff around these talks and our partnership with Confluent. Matt has done a lot of stuff on connectors, using Gradle builds, testing of streams. I would highly recommend looking at his blogs or his GitHub repos. I've definitely leveraged a lot of what he's done. And the team at Confluent is invaluable for the partnership we have at OPI. And both Josh's, the one that's here, the one that's not, and Cliff have been a great resource to me as I bumped up my coffee experience. Questions will be after 7:30. Feel free to reach out to me. I love talking this stuff, so you just have to pull me away. Thank you.